Alright, so for today's lesson, we're going to be looking at the triangle inequality theorem. We're going to be saying if we have these three side lengths, first, do they even make a triangle? Now, we studied that before the snow days, but we're going to review that part. And then the new part for today is if they do make a triangle, what kind of a triangle would they be? And so these are according to our angle classification. So let's just remind ourselves of these three kinds of triangles. We have the acute triangle, and remember that in an acute triangle, all three angles are less than 90 degrees. And so one example of how an acute triangle might look would be one like that. And then we have our right triangle. Now in our right triangle, we have one angle equals 90 degrees. It's not all three of them. It's just one. And so that could look like this. That's just one example of a right triangle. And then we have our obtuse triangle. And in our obtuse triangle, one angle is greater than 90 degrees. And so an obtuse triangle might look this way. So what we're going to be doing today is, you're going to have three measurements, right? And these three measurements represent the lengths of sides of a triangle, right? So if I had 3, 4, 5, and we are answering two levels of questions. Level 1, could these pieces even make a triangle? Are they going to be long enough for the corners to touch at the vertices? And then if they do make a triangle, what kind of a triangle is it? Alright? So here's these pieces 3, 4, and 5. We're going to do that as an example. And then I'll actually build with them. So if I have the numbers 3, 4, and 5, and those are the measurements of my three sides that might or might not be a triangle. So remember, the first thing that we do is we take the two smaller ones and we add them up, and we see, are they going to be bigger than the third one? Right? Do you remember this before the snow days? So we say 3 plus 4 is 7. Is 7 bigger than 5? Yes. So yes, these will indeed make a triangle. So for our second part, we're going to figure out what kind of a triangle. And the way we do that is with the Pythagorean theorem. So we have a squared plus b squared on one side, and then we've got c squared on the other side. And remember, c is for our longest one, so c is the 5 right here. So I'm going to write 3 squared plus 4 squared, and over here is 5 squared. And I'm trying to find out Are these equal? Are the legs squared bigger, or is the hypotenuse squared bigger? So if I do 3 squared, that's 9, and 4 squared is 16, and 9 added with 16 is 25. And then I do 5 squared, and that's 25. And so if they come out equal to each other, then this is a right triangle. So let's just actually take a look at building it. There I've got a 3, 4, and a 5. And when I put those edges together, do you see how that will make a right triangle there? So if I come in here and trace this, there's my right angle, right? But if the square of this hypotenuse, if this orange piece here were to get longer, right? Let's say it was longer than 5. Let me cut a longer piece. So if this hypotenuse squared gets longer, right? Well, if it gets too long, it's not even going to make a triangle at all, right? What if it just got a little bit longer? You see what would need to happen to this right angle? The right angle would need to open up wider, right? So if the hypotenuse squared is longer, then my triangle won't be a right triangle anymore. It'll become an obtuse triangle. But if it goes around the other way and the legs get smaller, or the hypotenuse is smaller and the legs are longer, then those little pieces of paper are frustrating me. If my hypotenuse is smaller, then it's going to go like this and be acute. So if the c squared is big, obtuse. If the c squared is small, acute. If the c squared is equal, right. All right, so let's do a couple of other examples. So let's say my numbers were 3, 4, and 6. So question 1, do these guys even make a triangle? So 3 plus 4, is that bigger than 6? 7 is bigger than 6, yes. Alright, so now let's see what kind. Biggest number is my c. So I'm going to do 3 squared plus 4 squared, and I'm comparing that with 6 squared. So 3 squared is 9, and 4 squared is 16, and that's 25. I'm going really fast because that's the same numbers as the other one. And then the 6 squared is 36. So this one is bigger. So this triangle is going to be obtuse. Because if this is 6, then my 3... and then my 4 is going to need to open bigger if this got bigger up to 6. It's not a very good drawing. So this is going to be more than 90 degrees. I don't like that picture. It'll be more like this. See, if it was only 5, this would go straight up and down and make a right angle. But since it's 6, it needs to open wider, and it's going to be obtuse. Alright, so let's do another example. I had 3, 4, and 4.5. So again, first I want to see, step 1, do they even make a triangle? Is 3 plus 4 bigger than 4.5? Well, again, 3 plus 4 is 7. 7 is bigger than 4.5. Check. So yes, they make a triangle. But now we have to see what kind of triangle. So we do 3 squared plus 4 squared. And would compare that to 4.5 squared. So 3 squared is 9, and 4 squared is 16, and that makes 25. Alright, 4.5 squared. I need a calculator for that. So I'm going to do 4.5. I'm going to square it. I'm going to get 20.25. So now my C is smaller, so that means this is going to make an acute triangle. Because when I go to put my edges together, now my hypotenuse is short. So when I go to put the 3 and the 4 together, this angle is going to be less than 90. Right? It's going to like squeeze in. Alright. So now I'm going to give you some to try. I'm going to give you 2 to try.